Hello, my name is Lawrence Waffey, and today I am presenting my final project for Machine Learning Foundations for Product Managers course. So this is my project on predicting power plant energy output using regression. I used a data set of nearly 10,000 hourly records from a combined cycle power plant, which includes variables such as temperature, vacuum, pressure, and humidity readings. My goal was to predict the hourly electrical output in megawatts using Excel without any code. What we quickly learned is that this is a regression problem. The target variable PE is continuous, and I was able to use R squared to measure how well each model explained variation in energy output, and the root mean square error, or RMSE, to see how far predictions were from actual values in megawatts. So what I was able to do was to evaluate all 4 input features and ultimately selected 2 models. So we had Model A. Model A used all of the features available. Model B used only temperature and vacuum. And this was a critical point in the exercise because we determined through correlation output that temperature and vacuum were most highly correlated with energy output. So now we have these 2 models. And then I was able to use a 70-30 split for training and testing. And I created a fixed validation set manually in Excel for model comparison. This slide shows the regression output for Model B, which used only those 2 features, temperature and exhaust vacuum. The Excel summary includes the intercept, feature coefficients, and R-squared value. This output formed the basis for calculating predicted energy values in the next step. And as you can see, the R-squared value indicates a very strong linear relationship, and the coefficients reflect how each variable affects energy output. Here I applied the model to the validation set. Each row shows the actual and predicted PE values, the error for each prediction, and the squared error used in calculating root mean squared error, or RMSE. Here in the formula bar, you can see the Excel formula I used to calculate RMSE across all rows. And Model B's RMSE was 4.99 megawatts, which was better than Model A's 5.84, confirming that a simpler model can still be more effective. So this spreadsheet view demonstrates that full model application from output to evaluation. This is an excerpt and not the entire spreadsheet, just to give you some idea. Now, this result shows that more features don't always mean better performance. The extra inputs in Model A may have introduced noise. Model B was able to capture the essential patterns more effectively. And this project confirmed that Excel can handle end-to-end modeling and reinforce the power of simplicity in predictive modeling. So thank you very much for watching my presentation. And this concludes my presentation of this project.